Hello class. Today we are going to start chapter 15, some natural phenomena. Let's warm up. Have you ever seen lightning? Speak about it, whatever you know and how you feel when it happens. Look at this picture of lightning and think about it. Let's know about lightning, charging by rubbing, types of charges and their interaction, equal and opposite charges, origin of electric charge on a body, different ways of charging a body, the story of lightning, do's and don'ts during a thunderstorm, lightning conductor, earthquakes. Now, let's talk about lightning. Let us recall some of the sparking phenomena which you might have often seen. First, when you take off woolen or polyester clothes, your hair stands on ends. If you take off these clothes in the dark, you see even a spark and hear crackling sound. Sparking from a loose electric plug in the socket. Sparking of loose electric wire on the electric poles when wind is blowing and shaking the wires. All these are sparking phenomena. Lightning is also a sparking phenomena on a large scale. In 1752, Benjamin Franklin, an American scientist, showed that lightning and spark from your clothes are essentially the same phenomena. However, this realization took 2000 years. Scientific discoveries are a result of hard work by many people. It can sometimes take a long time. Charging by rubbing. The ancient Greeks knew as early as 600 BC that when amber is a kind of resin, is rubbed with fur, it attracts light objects such as hair. To understand this, let us perform the following activities. Activity 1. Take a used ball pen, refill and rub it vigorously with a piece of polythene. Bring it close to a small piece of paper. Take care not to touch the rubbed end of the refill with your hand or with a metallic object. Repeat the activity with small piece of dry leaf, husk and mustard seeds. You will see that the ball pen refill attract the small piece of paper, dry leaf, husk and mustard seeds. Activity 2. Rub a plastic comb in your hair several times. Both comb and your hair should be dry. In fact, this experiment works best when the weather is also dry. Now, bring the comb near small pieces of papers. You will see that plastic comb attracts the small piece of papers. In fact, when a plastic refill is rubbed with polythene, it acquires a small electric charge. Similarly, when a plastic comb is rubbed with dry hair, it acquires some charge. These objects are called charged objects. In the process of charging the refill and the plastic comb, polythene and hair also gets charged. Let's try to charge some other objects that are familiar to you. Activity 3. Collect the objects and the materials listed in. Try to charge each by rubbing with the materials mentioned in the table. Record your findings. You can add more items to the table. Objects rubbed, material used for rubbing, attracts, does not attract, piece of paper, charged, not charged, refill, polythene, woolen cloth, balloon, polythene, woolen cloth, dry hair, eraser, wool, steel, polythene, spoon, woolen cloth. Types of charges and their interaction. We will select some objects from table for the next activity. Activity 4. Inflate 2 balloons. Hang them in such a way that they do not touch each other. Rub both the balloons with a woolen cloth and release them. What do you observe? Now look at this picture. Like charges repel each other. Now let us repeat this activity with the used pen refills. Rub one refill with a polythene. Place it carefully in a glass tumbler. Use the tumbler as a stand. Rub the other refill also with polythene. Bring it close to a charged refill. Be careful not to touch the charged end with your hand. Is there any effect on this refill in the tumbler? Do the two attract each other or repel each other? In this activity, we have brought close together the charged objects that were made up of same material. What happens if two charged objects made of different materials are brought close to each other? Let's Find out. Rub a refill and place it gently in a glass tumbler as before. Bring an inflated charged balloon near the refill and observe. Like in this image, interaction between unlike charges attract each other. Let us summarize the observations. A charged balloon repelled a charged balloon. A charged refill repelled a charged refill, but a charged balloon attracted a charged refill. The above observations clearly indicate that the charge on the balloon is of different kind from the charge on the refill. Thus, we can say that there are two kinds of charges. The charges of the same kind repel each other, while the charges of different kind attract each other. It is a convention to call the charge acquired by a glass rod when it is rubbed with silk as positive. The other kind of charge is said to be negative. It is now clear that two positively charged objects repel each other, two negatively charged objects repel each other. A positively charged object attracts a negative charged object. Thus, finally, it can be said that like charges repel each other while unlike charges attract each other. The electrical charges generated by rubbing are static. They do not move by themselves. When charges move, they constitute an electric current. You have been reading about electric current since class 6th. The current in a circuit makes a wire hot is nothing but a motion of charges. Now, let's see some equal and opposite charges. When a glass rod is rubbed with silk, the glass rod acquires a positive charge and at the same time, the silk cloth acquires the equal amount of negative charge. Similarly, when ebonite is rubbed with wool, the ebonite acquires a negative charge and the wool acquires an equal amount of positive charge. Thus, when two bodies are charged by rubbing against each other, they acquire equal and opposite charges. Testing charges on a body. We have seen that a charged body attracts another charged body having opposite charge. A charged body also attracts an uncharged body. The charged comb attracts the pieces of papers and husks which are not charged. Therefore, the attraction by a charged body does not indicate whether the other body is also charged or not. However, if the body being tested is repelled by the charged body, you are certain that it is charged. It has the same charges as on the charged body. Therefore, to test if a body is charged or not, bring near it a positively charged body and a negatively charged body one by one. If it is first attracted by both, it has no charge. Repelled by positively charged body, it is also positively charged. Third, repelled by negatively charged body, it is also negatively charged. Thus, repulsion alone is a sure test of charged body. Origin of electric charge on a body. Atoms are the ultimate constituent particles of any substance and atoms contain equal number of positive charge, protons, and negative charge, electrons on them, and as such, the atoms remain neutral because the positive and negative charges neutralize each other. The positive charge, that is protons, are firmly bound to the atoms while the negative charge, that is electrons, are loosely bound. In the process of rubbing, some of the electrons get transferred from one body to another and bodies get charged. When a glass rod is rubbed with silk cloth, some of the electrons from the glass rod move to silk cloth. Thus, the silk cloth becomes negatively charged due to the excess of electrons and the glass rod becomes positively charged due to lesser number of electrons. When ebonite rod is rubbed with wool, some of the electrons from wool move to the ebonite rod. Thus, ebonite rod becomes negatively charged due to the excess of electrons and the wool becomes positively charged due to the lesser number of electrons. Different ways of charging a body. Charging by induction. When a body gets charged simply by bringing it near a charged body, then this method of charging is called charging by induction. Now, let's look about charging by conduction. If an object gets charged when it comes in contact with a charged object, then this method of charging is called charging by conduction. The object acquires the same charge as that on charged object. Charging by rubbing or charging by friction. You know that when two objects are rubbed against each other, they get charged. For example, when a glass rod is rubbed with silk, the glass rod acquires positive charge and the silk cloth acquires negative charge. Let's look at this. Activity 5. Take an empty jam bottle. Take a piece of cardboard slightly bigger in size than the mouth of the bottle. Pierce a hole in it so that a metal paper clip could be inserted. Open out paper clip as shown in. Cut 2 strips of aluminum foil about 4 cm into 1 cm each. Hang them on the paper clip as shown. Insert the paper clip in the cardboard lid so that it is perpendicular to it. Charge a refill and touch it with the end of the paper clip. Observe what happens. In this image, a simple electroscope. What happens is there any effect on the foil strips? Do they repel each other or attract each other? Touch now other charged bodies with the end of the paper clip. Do foil strips behaves in the same way in all cases? Can this apparatus is used to detect whether a body is charged or not? Can you explain why the foil strips repel each other? The story of lightning. It is now possible to explain lightning in terms of the charge produced by rubbing. You learnt in class 7th that during the development of a thunderstorm, the air currents move upward while the water droplets move downwards. These vigorous movements cause separation of charges. By a process not yet completely understood, the positively charged collect near the upper edges of the clouds and the negative charges accumulate near the lower edges. There is accumulation of positive charge near the ground also. When the magnitude of accumulated charges becomes very large, the air is normally a poor conductor of electricity, is no longer able to resist their flow. Negative and positive charges meet, producing streaks of bright light and sound. We see streaks as lightnings. The process is called an electric discharge. In this image, you can see accumulation of charges leading to lightning. The process of electricity discharge can occur between two or more clouds or between clouds and the earth. Today, we need not get frightened by lightning like the ancient people did. Now, we understand the basic phenomenon. Scientists are trying hard to improve out understanding. However, lightning strike could destroy life and property. It is therefore necessary to take measures to protect ourselves. You have to remember these lightning safety methods. During lightning and thunderstorms, no open place is safe. Hearing thunder is an alert to rush to a safer place. After hearing the last thunder, wait for some time before coming out of the safe place. Finding a safe place? A house or a building is a safe place. If you are traveling by car or by bus, you are safe inside, with windows and doors of the vehicle shut. Do's and don'ts during a thunderstorm. Outside the house. Open vehicles like motorbikes, tractors, construction machinery, open cars are not safe. Open fields, tall trees, shelters in parks, elevated places do not protect us from the lightning strokes. Carrying umbrellas is not a good idea at all during thunderstorms. If in a forest, take shelter under shorter trees. If no shelter is available, if you are in open field, stay far away from all trees. Stay away from poles or other metal objects. Do not lie on the ground. Instead, squat low on the ground. Place your hands on your knees and your head between the hands. This position will make you the smallest target to be struck. Inside the house, lightning can strike telephonic cords, electrical wires, and metal pipes. Do you remember a lightning is an electrical discharge? During a thunderstorm, contact with these should be avoided. It is safer to use mobile phones and cordless phones. However, it is not wise to call up a person who is receiving your phone through a wired phone. Bathing should be avoided during thunderstorms to avoid contact with running water. Electrical appliances like computers, TV, etc. should be unplugged. Electrical lights can be remain on, they do not cause any harm. Lightning conductors. Lightning conductors is a device used to protect buildings from the effect of lightning. A metallic rod taller than the building is installed in the walls of the building during its construction. One end of the rod is kept out in the air and the other is buried deep in the ground. The rod provides easy route for the transfer of electric charge to the ground. Look at these images. A lightning conductor. The metal columns used during construction, electrical wires and water pipes in the buildings also protect us to an extent but do not touch them during the thunderstorm. Now let's talk about earthquakes. What are them? How to protect ourselves from them. An earthquake is a natural phenomenon that causes sudden trembling or shaking of the earth due to the disturbance under the earth's surface. It is caused by disturbances deep inside the earth's crust. Earthquakes can cause large-scale destruction, including loss of life and property. Earthquakes may sometimes give rise to tsunamis, which may sweep across coastal areas, causing destruction. The study of earthquakes is called seismology. Look at this picture, a building damaged by an earthquake. Richter scale. The magnitude or intensity of an earthquake is measured by Richter scale. This scale was developed in 1935 by Charles F. Richter, a US seismologist. Really destructive earthquakes have magnitudes higher than 7 on the Richter scale. Both Bhuj and Kashmir earthquakes had magnitude greater than 7.5. Causes of earthquakes. Look at this picture of the interior of the earth. Now we know that the tremors are caused by the disturbance deep down inside the uppermost layer of the earth called crust. The outermost layer of the earth is not in one piece. It is fragmented. Each fragment is called a plate. These plates are in continual motion. Look at this picture. This is the picture of earth plates. When they brush past one another or a plate goes under another due to collision, they cause disturbances in the earth's crust. It is this disturbances that shows up as an earthquake on the surface of the earth. Look at this picture of movements of earth splits. Tremors on the earth can also be caused when volcano erupts or a meteor hits the earth or an underground nuclear explosion is carried out. However, most earthquakes are caused by the movements of earth's plates. Although we know that for sure that what causes an earthquake, it is not yet possible to predict when and where the next earthquake might occur. Seismic zones. Since earthquakes are caused by the movement of plates, the boundaries of the plates are the weak zones where earthquakes are more likely to occur. The weak zones are also known as seismic or fault zones. In India, the areas most threatened are Kashmir, Western and Central Himalayas, the whole of Northeast, run of Kutch, Rajasthan and the Indo-Gangetic Plain. Some of the areas of South India also fall in the danger zone. This map shows the movements of Indian's earth plate. Protection against earthquakes. We know from the earlier pages that earthquake cannot be protected. We have also seen that they can be highly destructive. It is therefore important that we take necessary precautions to protect ourselves all the time. People living in seismic zones where the earthquakes are more likely to occur have to be specifically prepared. In these zones should be designed so that they can withstand major tremors. Modern buildings technology can make it possible. It is advisable to make the structure simple so that it is quake safe. First, it is better if the cupboards and shelves are fixed to the walls so that they do not fall easily. Consult qualified architects and structural engineers. In highly seismic areas, the use of mud or timber is better than the heavy construction material. Keep roofs as light as possible. In case the structure falls, the damage will not be heavy. Since some buildings may catch fire due to an earthquake, it is necessary that all buildings, especially tall buildings, have firefighting equipment in working order. Be careful where you hang all wall clocks, photo frames, water heaters, etc., so that in the event of an earthquake, they do not fall on people. The Central Building Research Institute, Roorkee, has developed know how to make quake-proof houses in the event that an earthquake does strike. Take the following steps to protect yourself. Number 1. If you are at home. If you are in bed, do not get up. Protect your head with a pillow. Number 2. Stay away from tall and heavy objects that may fall on you. Number 3. Take shelter under a table and stay there till shaking stops. If you are outdoors. If you are in a car or a bus, do not come out. Ask the driver to drive slowly to clear spot. Do not come out till the tremors stop. Find a clear spot away from buildings, trees and overhead power lines. Drop to the ground. Now, let's recall the chapter in a nutshell. Lightning is the electric discharge between two clouds or the cloud and the ground, or the two parts of a cloud. Some objects can be charged by rubbing with other objects. There are two kinds of charges, positive charge and negative charge. Like charges repel and unlike charges attract each other. Repulsion alone is a sure test of charged body. Three processes of charging bodies are rubbing, conduction and induction. The electrical charges produced by rubbing are called static charges. When charges move, they constitute an electric current. An electroscope may be used to detect whether a body is charged or not. The process of electric discharge between clouds and the earth, between clouds and the earth or between different clouds causes lightning. An earthquake is a sudden shaking or trembling of the earth. The waves generated by an earthquake are called seismic waves. The instrument which records the seismic waves is called seismograph or seismometer. Let's see these keywords. Crust, upper layer of the earth. Discharge, removal of electric charge from the body. Earth's plates, plates in which earth's crust is divided. Earthquake, shaking of the earth's crust due to release of energy. Electroscope, an instrument to test charge on body. Lightning, huge electric spark during clouds in the sky. Conductor, a material which allows electric current to pass. Negative charge, a charge due to gaining of electrons. Positive charge, a charge due to losing of electrons. Richter scale, a scale to measure the strength of earthquake. Seismograph, a tool to measure the strength of an earthquake. Thank you, students. Now let's meet in the next class.